We are starting a new chapter, Chapter 7. We'll start this before break and then continue it after break. And Chapter 7 starts with talking about what an exponential function or an exponential model is. Now, this is something that you have already explored the basics in Algebra 1, so hopefully a lot of what I'm telling you today is relatively much of a review type of material. So we're just going to first get you comfortable with how we enter things in our calculator, kind of get the technology going today. So if you are asked to work with a function, and especially something that's maybe a little harder to work with, like an exponential function, to graph it on your calculator, you're going to go to y equals, and you're going to type in the equation. So we're going to type in this first one, 3 to the x power. And then I'm not sure the last thing you graphed in your calculator. So if you'd hit zoom 6, that's going to guarantee we're all looking at the same window. And what you're going to see is you're not going to see it at first. It kind of almost like merges into the x-axis, and then it's going to go up sharply very quickly. So if I want to fill in a table, if you go to the table button on your calculator, which is second and graph, you actually will get a table to show up on your calculator. So if you're trying to fill in a table very quickly, this is the fastest way to do it. The other way to do it, if you don't want to use the table feature, is you can just start plugging in the x values directly into the equation and then one at a time get the values. So when I put 0 in, I get 1. When I put 1 in, I get 3. 2 is 9. 3 is 27. The one thing I am going to point out is 0, 1. And the reason I'm pointing out that is your y-intercept. Anytime you have 0 in your x column, in your x coordinate, that is going to be a y-intercept. And we're going to use that as we go on today. That's going to be something you'll be asked about. So the second one, go back to my calculator. I'm going to type in, go to y equals. I'm going to type in 1/2 to the x. Actually, probably the best way to type in a fraction is to use parentheses. So I'm going to go back and fix that. If I go to graph, I'm going to see this graph. You'll notice it looks very similar to the graph that we did earlier. However, this graph is dropping, and that's going to be a difference in the type of exponential graph it is. If I go to the table, second graph, when I put 0 in, I get 1, and then 0.5, then 0.25, then 0.125. And I'm just going to draw a little picture next to these to kind of show you what you should have seen on your screen. Again, that is your y-intercept. When you look at these two graphs, these are the two types of exponential functions we're going to talk about today. We're going to talk about growth versus decay. Growth is going to be when it's going up very rapidly. Decay is going to be when it drops very rapidly. When we talk about something growing exponentially, you usually use that terminology with something that's growing very, very quickly, or decaying exponentially, something that's decaying very, very quickly. So an exponential function is what we're working with. Exponential functions will have the form y equals ab to the x power. This is definitely something you want to jot down. You want to have this form because you're going to be writing a lot of things in this form throughout the day. Your b value is called your base, and your base cannot be 0. It has to be a value bigger than 0. So you're going to have b values that are whole numbers. You're also going to have b values that are fractions or decimals. It is always a constant. So if I want to fill in this table, actually, we already did one similar to this. Let me go to the next one. So again, let me pause for a second. Make sure you have this formula. Make sure you have this a times b to the x formula, because that will be our basic formula for anything that is exponentially a function. So let me do one that's a little more involved. So let's do this one. So we're going to grab our calculator again. So we're going to go to y equals. We're going to type in 1/2. I do think it's nice to put fractions in parentheses, and then times 3 to the x. I know this has the 3 in parentheses, but I actually don't think it's necessary to do that. If I hit graph, I'm going to see a picture. And here you'll see this picture. It's growing again very rapidly. When I go to my table, if I go to second graph, I'm going to actually scroll up a little bit so I get all my values. So I want to put in -4, so that would be 0.006, and then 0.018, 0.006, 0.018, 0.055. It's going to round up to 0.056. When I put -1 in, I'm going to get 0.16 repeating. When I put 0 in, I get 0.5. 1 is 1.5. Go down a little bit here. 2 is 4.5 and 3 is 13.5. The one that I really want you to focus on, again, is where you have 0, because that's your x-intercept. So if I put a point there, right at the half mark, there my x-intercept. When I draw it, so I'm not going to draw a ton of points here. The idea is that it's getting really big really quickly, so you're going to draw it looking like that. That is an example of what we're going to call exponential growth, because it's going to grow very rapidly. And your x-intercept is going to be your 0 and then whatever number is next. And you can also just plug 0 directly into here. If you plug x equals 0, that will give you your y-intercept. So another thing you're going to be asked to do is you're going to be asked to do the reverse. I give you a table, you tell me what the exponential model is. So again, our formula is going to be y equals a times b to the x power. Your a value is going to be your y-intercept. So when you look at your table, they have to give you that piece of information for your a value. So you're going to put a 5 for this first one in for a. For the second one, you're going to put a 0.02. Your b value is going to be found by figuring out, what did we multiply to get from here to here? What did we multiply to get from here to here? That's what your b value is. It's like a multiplier. So to quickly find that, to find your b value, you're going to divide your y coordinates. So you're going to say, well, what is 15 divided by 5? Or you could do bigger numbers, 45 divided by 15 or 135 divided by 45. It's going to consistently be the same multiplier. This one is tripling every time. So when we say it's growing exponentially, it's growing by a factor of 3. So your model is 5 times 3 to the x power. Or you can also write it with multiplication sign. You can write it like this. Delta Math will accept either one. For this one over here, my a value is 0.02 because that's my y-intercept, and my b value is going to be found by dividing the y by the previous y. So on my calculator, if I take 0.01, let me get out of that, 0.01 divided by 0.02, I get a half. So my model would be 0.02 times 0.5 to the x power. If your growth factor or your b value is bigger than 1, your graph should be growing. It should be multiplying. If your b value is less than 1, then your graph should be decaying or dropping. So those are just some basics of what you should know from a table, either to fill in a table or to complete a table on your own.